Hey guys, this is just a quick preview of the upcoming video I have here tonight. Just a quick demo of this coil running at 26 volts going into it. I just had it hooked up to some of these caps here. As you've seen in previous videos, I would just turn it on but I have all the batteries. So I have some 2S's, I have 3S's, I have 4S's, and I have some 6S's, which are over here. So I have these here. There's 6S's and I have another one right there. It's being charged. So what I'm going to do is get each cell. So what I want to start with just to test is 185 volts. So I need 48 cells. So I use all my 4S's. I have 4S's and 5 6S's. And 1 2S I'll use. And that should give me my 48 cells to get it at 185 volts at 3.85 volts per cell. So I'm just charging up the battery full, and then I'm going to put it onto the ZK Tech and discharge it. So I'll need to discharge like the 6S to 23.1, 4S 15.4, 2S to 7.7. But that's going to be in a later video. You're going to see these running at 185 volts with the 4S's and 1 2S. They're all the same batteries, same capacity. Really good batteries. Highly recommend these ones. I get over 9 amp hours with 1 amp draw out of these ones. There's 60C rating. You can pull 6,600 milliamp hours out of it when you bring it down to 3.2 volts at 1C rating. So you're pulling 6.5 amps. That's what you get when you bring it down to that. But yeah, you're just gonna see me charge up some of these caps in this video here. Just a quick demo of it running at the high voltage with the same type of current on the input with the 26 volt battery. And we'll be going from there. I haven't done the test yet, so I'll be starting that this weekend. Just getting everything prepped now and hopefully be able to start it tomorrow or something. But I'll just do a quick clip here of the video I'm gonna have posted, and it's gonna be with this coil and that circuit. I've added another transistor and a couple different diodes from what was in it when I first started testing this coil, but it's this one here anyways. It's just running at 26 volts. And just a quick demo of what it does at 200, and I think it can go up to 230 pretty easily with the same current. You know, that's the voltage going in, but it'll do it at 26 volts with that same current at 200 volts on the output. So almost 3 times the potential with the same, well, at 26 volts, same current levels though. Twice the power going in, you could say. But enough. I'll post that video, and thanks for watching, guys. Okay, I've changed the transistor. Let's do this again. This one's going to be more suitable for 12 volts, but if I want the real high potential, once I get a bigger cap bank, a higher voltage, then I'll be able to use this one. Turn this on. There's the current, the voltage in the caps. Drops below 20 at about 190 volts. So you're getting all that potential at this high voltage now with the same cost as what this one does at these lower voltages. This one's been going for can't remember, 5 hours maybe, I can't remember. So it's using about 10 milliamps and charging at that voltage, whereas this one will be doing that, pulling that same current at this voltage, which means an insane amount of, like, more than, it's almost 3 times as efficient. Well, it is. It's over 3 times as efficient. If that was 70 volts, we're there now. 210 is 3 times that, the same current going in. Because it charges at the same rate as what that one was. There's higher potential, which means watts. Still climbing. Can hear it ringing still. Just unhook this. That's what I got here. I just want to discharge it a bit. Oops. Too many wires here. The circuit is exactly the same. The only difference is the coil. It's good like that. There it goes. But there'll be more coming with this coil. Definitely. And I'm going to be making the other one too.